Energy storage system, unit number 2, battery and its types. So, general aspects on power system, classification of batteries, classical examples of power systems, special view on lead acid system about lithium batteries. So, these are the topics we are going to cover in unit 2. So, battery, it is a source of energy obtained by the conversion of chemical energy from chemical reaction into electrical energy. Thus, batteries represent a silent form of energy producing chemical devices which generate electricity on demand. So rapidly with the energy resources and oil fields are consumed at present and in the future will depend on the rapidly with regions of the world industrialized, the rate of population growth, the ultimate level of human desires to possess material goods and the effort that is made to accelerate production. The growing concern with managing the cost of military spacecraft, portable electronics, implantable medical devices, communication technology, etc. So the importance of preserving our green environment mainly because of very high rate of industrialization, modernization and partly due to population explosion etc. has placed an increased emphasis on efficient power sources. So batteries are rechargeable. So components in a battery system, cathode, anode, electrolyte, and there is a separator and the container. So this is the cell construction. So we are having here is this is electrolytic solution and this is anode and this is cathode and this is a container and this is a separator between the anode and cathode. So cell reactions, anode reaction is an oxidation reaction which releases electrons. So anode is a negative electrode in the electrochemical cell. Cathode reaction is a reduction reaction which consumes electrons. So cathode is the positive electrode in the electrochemical cell. So electrolyte is an ion conducting medium which conduct ion between the electrodes so that the above reactions can take place. So this is the working principle. Classification of batteries: primary battery for single use only, secondary battery for repeated use or rechargeable batteries. So, primary battery is non rechargeable, cell reactions are irreversible, self discharges whether used or not. So, Lagrange cells are zinc copper cells, popular low cost system. Applications: torchlight, portable radios, toys, novelties, etc. Manganese or magnesium dioxide cells, high capacity system application, military communication equipment, voting machines, etc. So reserve battery, one of the cell component, usually the electrolyte, is kept isolated from the rest and is added at the time of need. So seawater activity battery, manganese, copper dichloride, magnesium or AgCl applications, tropoids, sea beacons, mainly in meteorology and different fields. Lithium or Fe2 thermally activated battery applications in missiles. So secondary battery rechargeable cell reactions are reversible. So these are the types of secondary batteries: lead acid battery, nickel cadmium battery, nickel ion battery, nickel metal hydride battery, lithium ion battery, and lithium ion polymer battery. Lead acid battery, so the anode is lead, cathode is lead dioxide, electrolyte is H2SO4, cell voltage is 2 volt. Applications: automotive, starting lighting ignition, electrical vehicle, emergency power utilities, portable tools, industrial trucks, etc. Nickel cadmium battery, the anode is cadmium, cathode is NiOOH, electrolyte is KOH, potassium oxide, cell voltage is 1.2 volt. Applications: aircraft batteries, communication equipment, memory backup, photography equipment. Nickel metal hydride battery, anode MH, cathode NiOOH, electrolyte KOH, cell voltage 1.2 volt. Applications: portable electronic devices. Nickel ion battery, anode is nickel Fe, cathode is NiOH, electrolyte KOH, cell voltage 1.2 volt. Applications: railway signaling, stationary power supply, etc. Lithium secondary battery, anode is lithium metal, cathode is lithium COO2, electrolyte LiPF6 in ECRPC, Cell voltage is 4 volt. Applications electric vehicle, portable electronic devices, etc. Lithium ion battery, the anode is carbon, cathode is LiCOO2, electrolyte is LiPF6 in ECRPC, electric cell voltage is 4 volt. Applications electric vehicles, cell phone, camcorders, laptop and palm-top computers, portable electronic devices. Lithium polymer battery, anode lithium, cathode LiCOO2, electrolyte, solid power film, cell voltage 4 volt. Applications electric vehicles, credit cards, slim electronic devices. Lithium-ion polymer battery, anode is carbon, cathode is LiCOO2, electrolyte is solid polymer films, cell voltage 4 volt, applications, electric vehicles, portable electronic devices. Lead-acid battery, anode is Pb, cathode is PbO2, electrolyte H2SO4, cell voltage 2 volt. So this is the chemical reaction. So I'm explaining for only one battery. Reactions during charging. So PbSO4 plus 2H2O, which gives the chemical reaction PbO2 plus 4 hydrogen plus SO4 2 minus and 2 electron minus. So 2H2O gives O2 plus 4H plus 4 electron minus. That is what I mentioned in the positive plate. At negative plate, PbSO4 plus 2 electrons, which will give Pb plus SO4 2 minus. So 2 hydrogen plus 2 electrons will give H2. So the overall chemical reaction is 2 PbSO4 plus 2H2O, which will give PbSO4 plus 2H2SO4 plus PbO2. So that's all about unit 2.